So as a continuation, we are going to consider question number 8 of our section B, paper 2, still on our June 2025 exam. So we were given this part of our linear programming. So we just want to see how to attempt this type of a question where we had Mr. Ndou wants to plant peas and beans in his 5-hectare field. Okay, so, okay, let's see here. So there are two things to be planted, okay, the peas and the beans, but they are supposed to be planted in a 5-hectare field, okay? So this is important. Then peas need 4 bags of fertilizer per hectare. Beans need 2 bags of fertilizer per hectare. They are referring to the fertilizer this time, per hectare. Whereas all these bags that are there, he has 16 bags. He has 16 bags of what? Of fertilizer together. So you must be very careful there. The total number of bags of fertilizer together, they are 16. Then we are told that Mr. Ndou, he needs to plant at least 1.5 hectares of beans and this and that. All right, no problem. So with this information, the question was now, okay, let's see the information. The question, taking X to represent the area where beans are to be planted. So X is supposed to be area for beans, and Y be the area where peas is to be planted. So that is the condition. So meaning to say X is going to represent the part of what? Of beans. Then Y is going to represent peas. So let's start. The question is, write down 4 inequalities that satisfy the above conditions. There are 4. From this information, yes. Okay, let's figure out these inequalities. The first one, where can we obtain it from? That is the question. Okay, let's talk about the land where the peas and the beans are to be planted. We've got 5 hectares. So meaning to say whatever that is going to occupy for beans and whatever that is going to occupy for peas must be less than or equal to this. When combined together in this land that we have, it must be less than that or equal to that. You can grow, you can plant the whole of the land, the 5 hectares, or less than that. So you cannot exceed what you have in terms of the land that you are given there. The land that you're using is 5. So everything to be planted must be either less or equal to that. Then let's go to the fertilizer now. They are saying peas, which is Y in this case, need 4 bags, meaning to say that's 4Y. Of what? Of fertilizer. And the beans, which is X, needs 2 bags, meaning to say 2X. If we combine these bags together, 2X plus 4Y like this, in terms of the bags of fertilizer that Mr. Ndou has, it's what? We are given that he has 16 bags. So he can use less than 16 bags of fertilizer, or he can use all the 16 bags. So it must be less than or equal to 16. The amount of fertilizer to be applied on the beans and on the peas. Then the other part, he needs to plant at least here, very, very important, greater than or equal to what you are given. At least 1,5 hectares of what? That is the condition of beans, where beans is X. So X must be greater than or equal to 1,5 at least, starting from that. And another one, at least 1 hectare of what? Of peas, which is Y. So Y must be greater than or equal to what? So these are the 4 inequalities to be represented that were needed. Then answer this part on B. Answer this part of the question on a sheet of graph paper. This part must be done on a sheet of graph paper. Okay, so let's see about that information. The point XY represent X hectares of beans as we are given before, and Y hectares for what? For peas. So using a scale of 2 centimeters to represent 1 unit, on both axes. For X is greater than or equal to 0 and less than or equal to 8. We are supposed to take our X values in within this interval from 0 to 8, where 2 centimeters represent 1 unit. So if we are to represent this, we can say this is our x-axis. Then from 0, we are going to be having 1, 2, 3, 4, 5, 6, 7, 8. 1 unit, 2 centimeters. These the smaller boxes, if you count 10 of them, 2 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I talked about that, guys. Then same thing, if we are to represent for the Y values, because these are for X, then we also have for the Y axis. From where to where? From 0 to 5. In within that interval from 0 to 5. So that was going to be 1, 2, 3. Then we need 4 and what? And 5. So that's it. So from 0 to what? From 0 to 5. So this is what we are going to have, something like this. Then we can represent our inequalities. As we do that, you're supposed to draw a graph indicating clearly by shading the unwanted region, and they even indicated that in bold, guys. What is not needed? The unwanted region. Okay? The region in which XY must lie. So you must shade what is not needed. So let's start with the first inequality. The first inequality, guys, is X plus Y, which is equal to 5. So from this one, X plus Y must be equal to 5 as an equation. You draw the line of X plus Y, which is equal to 5, okay? So how can we draw this one? We can use a table. It's up to you guys, as we have got the table of values method. You choose your values in within the X values from 0 up to what? To 8. It's up to you. Or you can simply use the double intercept. Like I said before, the double intercept. The double intercept, you ask yourself to this condition. This is the condition of double intercept. When X, remember a point is XY, a point is made up of XY. When X is equal to 0, what is the value of Y? You do not know. And when Y is equal to 0 this time, what is the value of X? You're done. That is double intercept. 2 points, they're enough for us to have a line. So let us ask ourselves this condition. When X is equal to 0, what is the value of Y? Substitute into the equation. X plus Y is equal to 5. But X, we know it is 0, this one. So what is the value of Y? Y is equal to 5. Just like that. So that's a point, 0.5. The same thing when y is equal to 0. If you take that equation back, in place of y here, you put a 0. It means x plus 0 is equal to 5. So x is equal to what? X is equal to 5. You substitute into here in place of x. When y is equal to 0, you substitute where y is, you put a 0 there. So it's just like there's nothing. So these 2 points, they're enough. 0.5, where do we have the 0.5? In the y-axis. That is just like we are talking about the y-intercept. So that's 0 versus what? Versus 5. You mark the point. Remember the other one was 5 is 0. So 5 is 0 in the x-axis. That is our x-intercept. So these 2 points are enough for us to have a line. And what are we going to have in terms of the type of the line? Is it going to be continuous or a broken line? Because of the inequality sign less than or equal to the equal to there, we are going to have what? A continuous line. So we are going to represent with a continuous line. That is the condition. So these 2 points, you join them with a continuous line. So let us just have something like this. These 2 points, 5 and 5, with a continuous line, just like that. So you write the equation on the line here. You are going to write the equation that we had, x plus y is equal to 5, or you wrote it as y plus x. It's not a problem. So x plus y is equal to 5. Then we must shed. Which region are we going to shed? I said, guys, when x and y are on one side of the equation like this, as it is like this, when they are on one side, x plus y is equal to 5. But in that case, it is less than or equal to 5. As long they are on one side like this, you can tell on your graph, if your line is like this is the greater side, this is the lesser side. So on our graph, we need the lesser side here. X is less than, the lesser side is the one that we need. So what is that we do not need? The one that is represented by a greater than sign, because here it's less than. Where the less than is where we need. So the part of the greater than, what are you going to do? This is our unwanted region. We are going to shed that region, just like that. Or you can use points, okay? You can use points. You test by points. But I said, if you're given a line, guys, this is your Cartesian plane. You are given a line like this. This is the greater side. This is the lesser side. If you are given a line, all right, if you are given a line like this, a line which is like this is the greater side, this is the lesser side, provided that x and y are on the same side of the inequality, then the number or the constant is on its own, just like that. So that is how we can present. Yes, you can use those points, you test them, it's one and the same. All right, and also on this inequality, you could have reduced this inequality, it's fine, or you can leave it like this. The second one, this one, where we are going now to the number 2. You could have reduced it. Divide by 2, it's fine. Or you can leave it like that. All right, so let's represent the second inequality. Same with the last one, I can even use that double intercept. So this is an equation. It is equal to 16. So double intercept, just like the previous case. Remember, we need 2 conditions. 2 conditions, when x is equal to 0 and when y is equal to 0. So when x is equal to 0 here, what is going to be the value of y? You put a 0 here, so it means 4y is equal to 16 divided by 4 divided by 4. So y is equal to what? Y is equal to 4. So this is it. You are done. The same thing, the second one, when y is equal to 0 this time, in place of y, put a 0 there. So it means this one is back to normal. It is 2x. So we now have 2x plus a 0. There's nothing here. So 2x is equal to 16. Divide by 2. So x is equal to what? 16 and 2, that's 8. So this one was going to give us 8. So these are the 2 points that we are going to represent on our Cartesian plane. That is the y-intercept and the x-intercept. So that's 0 versus 4. All right, let's mark this one 0 versus 4. Okay, this is 0 here, and this is 4. You mark your point. And another one that is 8 versus 0. 8 versus 0, which is here. So just like the previous case, using our ruler, join the 2 points, and that's a continuous line again because of the inequality sign that we are given, less than or equal to. So it is going to be a continuous line. And as you can see, this line, all right, let's just finish our equation. It was, then it was 2x plus 4y, which is equal to 16. So as you can see, guys, this line is still, it is just the same shape. I mean, the same slope as this one. So this is the greater side, this is the lesser side. Just like what we had, this is the greater side, this is the lesser side. As we need which side? We need the lesser side. So the lesser side is the one that we need. The greater side, we do not need that one. We shed what we do not need. So we shed this whole side where the greater sign is. All that side is invalid in our question. We are not going to consider that part. So we shed the part that we do not want, the unwanted region. That is the case. So we need this region. It is going to remain clear as it is. Another one, it was x is greater than or equal to 1,5. There we do not need a table. We do not need a double intercept as it is, guys, at 1,5, where x is at 1,5. So on the x values at 1,5, that is in between 1 and 2. In between 1 and 2, that you're supposed to count 5 boxes. 1, 2, 3, 4, 5. So this is where we're going to have, and it is going to be a continuous line greater than or equal to. So that's a continuous line that you are going to have on that part. Okay, so let us just try and have our continuous line at 1,5. So we are supposed to go up. So remember our 1,5 is here. So we're just going to take our line straight up. So this is the condition. So straight going up. So you can write the equation of the line x is equal to 1,5. As it is, x is equal to 1,5, the equation. But which side do we need? We need the greater side, the bigger side. So as we've got a vertical line like this, this is the greater side, this is the lesser side. So as we need what? The greater side. So we need this side. So this one is wrong. We shed that side. So we're going to shed the left side of our line. So this is it on 1,5. We are going to shed on this left side. That is our condition, just like that. So all this side, we do not need it. Then the last one, it is y is greater than or equal to 1. So we need the line of y is equal to 1. A continuous line in that case, where y is equal to 1. Y is equal to 1 at this point. So there we're just going to need a continuous line, which is a horizontal line like this. So all these lines were continuous. There was no condition of a broken line. Okay, so that's it. So, okay, on the shading part, let's write the equation first. Y is equal to 1. Then which side are we going to shade? Remember, we are dealing with y is equal to 1. It's a horizontal line. So the greater side is on top, the lesser side is below. As we need what? Greater than, we need on top. So the one that is below is to be shaded. We are going to shade below this line of y is equal to 1, below this side. So you shade below the line. So that's it. So after shading, we can see that there is a region that is remaining, which is not shaded. In this region, that is where our answers are supposed to be taken, in this region. So in this case, we are going also to consider even the points which are on the continuous lines, even though it is shaded, as long it lies on the continuous line. You can take those points. So that is the region that every part here has to be taken to answer our questions which are to follow. So that is how we could have actually attempted this question. You just needed all the lines, just like normal equations, then you shade according to what you're given on that part. Then the other question was, the estimated profit is $30,000 per hectare for beans. Remember, beans, it's X. And $40,000 per what? Per hectare for peas. All right. I also want you to take note of the presentation of the dollar, the way that it is presented, was most of the case when I talk about these guys, you think maybe it's just a joke or something. This is how we are supposed to have this presentation, the same way that we see it. Not to have that dollar sign for those chain or necklaces. No. You're supposed to have that one, a proper presentation. Anyways, it's not about that presentation here. It's about, the question is, calculate the maximum profit, the maximum possible profit. Because why are they saying possible? Because there are profits there that can be obtained as long we are looking into the region where the peas and beans were being grown here. There's a profit. But out of those profits that we can obtain out of the region where there is peas and beans at the same time, the question needs us to focus not only on that, but the maximum. They can work on the least, the smallest. Yeah, they want the maximum. So how can we get that one? Okay, this is how we answer this question. You must obtain a point in X and Y. Remember, X representing what? The beans. And Y representing what? The peas. So you must obtain a point which is in X and in Y. Then take that value to multiply it to the what? To the profit. Because already, the profit is already given. They told you that 30,000 is needed for what? 30,000 is needed per hectare for beans, which is X, plus 40,000 is already given as our profit for each hectare that you have for what? For peas. They already gave you that. So what you just need is a point here which satisfies X and Y for a maximum profit. So we must find something that we put here for X, something that we put here for Y. And the value that we get here is supposed to be the maximum out of all the possible values. This one must be maximum. So take any point, guys. It's a trial and error type of a question. You try. It's a trial and error. Take every possible point that you think of, any possible, in this region which is not shaded. Okay, let's just go through and see which points can we work with. This one is 1,5, remember? So meaning to say we can take 1,5 versus 1, 1,5 versus 1,1, there are so many points, 1,5 versus 2, 1,5 versus 3, 1,5 versus, it's going to be 3,1, 3,2, all these, they are points. You move on from that 1,5 to 2. This is 2 versus 1, 2 versus, oh, there are so many points that are are there. Out of these points, 2 versus 3 here, you can take this one. It is this point 2, 3. Okay, remember I said about this bold line, I mean the continuous line that we are seeing here. If you're working with a continuous line, you can take the point that lies on a continuous line. Not broken, continuous. So all these points, this one is going to be 3 versus 2. There's a point there. We also have this point 84, 4 versus 1. This is 3 versus 1. All these points, there are so many points in that region that you can work with. Try them. Try them. But working with maximum values, there is no need for me to try a point such as 1,5 versus 1. While least there's a 1,5 versus something there on top. So at least I can try 1,5 versus 3, something. There we try the value because that it's part of the land, 1,5. It's part of the land. As we can see, it's part of the presentation. So those points can be presented. But there was nothing that we're going to take to have from those ones or on those points. So what I wanted you to do here is to try this one. You try this one 2 versus 3. This one 3 versus 2, 4 versus 1, which are on the maximum. Remember, we're dealing with maximum. So try also to deal with what? The maximum side. Try to deal with the maximum side. So what I'm simply trying to say is that here it's a point 4 on the x, y, which is what? 1. So we have got 4, which is a point. Here, let us have this way. So this is 4 versus what? 4 versus 1. X is 4, y is 1. This one, x is 3 at this point. The value of y is what? The value of y is 2, and so on. Here x is 2. X corresponds to 2 here down. But the y value that we have there is what? Is 3. So try this point. This is x, y, it is x, y, it is what? It is x, y. You substitute these points, just like 2, 3. 2, 3. It is x, it is y. So in place of x, you substitute a 2. Y is what? Y is 3. And you see the value that you're going to get from it's a trial and error, like I say, you test. So you're going to see that if it is a condition of a 2 and a 3, it was going to give us 18,000. If you multiply this, was going to give us 180,000. I mean, 180,000. Okay. There was another one. We used 2, 3. We used, okay, I wanted to take 3, 2. But anyways, we used 2, 3. Let's use 3, 2. 3, 2. Okay, 3, 2. 3, 2. When x is what? When x is 3, y is 2. So in place of y, you just substitute, we multiply like that. So the 3, 2 was going to give us 170,000. So guys, it was going to be a trial and error. You're going to see that the maximum value was going to happen on this one, 180,000. And 180,000 came from what? 2, 3. So the question was to calculate the maximum profit, not to give us the point which gives the maximum. No, the maximum is this one. So this is our maximum possible profit. The question can be, give a condition which will give the condition which will give the maximum possible condition is 2, 3. The question is not asking about the condition. It is asking about that maximum profit. So be very careful there. The question could have been asked like, calculate, state which condition will give the maximum possible profit. When they refer it like that way, you answer it as a point. The condition which gives is what? Is 2, 3, or x is 2, y is equal to 3. So let us be very careful when we are attempting our questions. So this is how we were supposed to have our graph for this linear programming. It is very, very important that you do go through your revisions, question papers also, to figure out how do they ask these typical questions, because it is going to be a repetition throughout. This one is just going to be a repetition throughout. They do repeat these questions. So just make sure you do work out as many questions as you can.